All right, here we go. This is a quick intro to slope. Pens down, please. Eyes up here. Here it goes. Everybody look up, please. All right. So let's say I go on the internet and I search for a map of Imperial. This is what it looks like. Given the satellite view, this is what it's going to look like. There it is. All right. And this is downtown Imperial. Does everybody see it? Now, check this out. If you don't see where we're at, down here, do you see the Imperial High School at the bottom left? And we are way up here at Frank Wright Middle School. So let's say, check this out. Let's say I was at the high school this afternoon, and I was talking to a parent that they're going to enroll their kids here in Imperial. One of them at the high school and one of them here in Frank Wright. So we were here. And you see us standing right here in front of the high school? You see us? Yeah, so we're standing right there. And they're saying, yes, how can I get to Frank Wright? I need to enroll my daughter over there. I said, well, Frank Wright is way over here. Okay? So to get there from here to there, all you have to do is drive all the way across like this and crash through all the houses. And that's how you get there. Right? Do we give those kind of directions? No. Right? We usually tell them you need to take 3 blocks down and 4 blocks up, or whatever the instructions. Is that correct? Yes. So check this out. If I was to tell them, number one, I need for you to, first of all, we're here at the corner, and you're going to have to take, let me make this a little bit bigger. You're going to take 1, 2, 3, 4 streets down. You're going to go 4 streets down. Bless you. How many streets down? 4. Okay. From there, you're at this corner. At this corner, you're going to take 1, 2, 3, 4, 5, 6, 7 streets up. 7 streets up. Right? Those are pretty much the directions. Now, somebody said, well, Mr. Q, why can't I just tell them to go through the parking lot here and say, just go 1, 2, 3, 4, 5, 6, 7 streets up. Isn't it the same? Sure, it's the same. And from there, I'll tell them, and then take 1, 2, 3, 2, 3, and 4. 4 streets down. Is that correct? Now, check this out. What I just did is called a slope. The only reason that we don't see the slope because it needs to be written as a fraction. Now, check this out. Who sees a fraction bar here with a line? Yeah, right there. Everybody see it? Yeah. Now, check this out. Notice when we take steps up, it's like if we were on the y-axis. Is that correct? Yeah. So how many steps did we take up? 7 steps up. And how many did we take to the right? 4. Who sees the fraction 7 over 4? This is what we call the slope. The slope is the rate of change of the y to the rate of change of the x. Everybody got it? That's a quick intro. So just to be a little bit more formal about it, let's get our objective going. Our objective for today is I can define and find the slope of a line. I can define and find the slope of a line. Let's read it together. 1, 2, 3. I can define and find the slope of a line. And we just rapped, didn't we? Yeah. Man, that sounded pretty good. All right, so we are going to define, number 1, and we're going to find the slope of a line. So for this one, you are going to need your Frayer model, so get that ready. And our concept for today is slope, okay? So here we go. Even though we're still on 2 variable equations, and once again, we went from linear functions to linear equations. Is that correct? We're still on linear equations, but today I'm going to give you a quick intro to slope. So here we go. Frayer model, slope. Definition. Slope is a change in y value, in parentheses, which is called a rise, per unit of change in x value, in parentheses, which is called a run. Once again, slope is a change in y value, which is rise, per unit of change in x value, which is run, comma. It's always the same, which is In other words, you can call it a constant rate of change, okay? And it's also known as rise over run. Who remembers that one from last year? Okay, rise over run, that's what we call it, or also known as the slope of a line. Examples of the different types of slopes, here they go. There's 4 different ones. And by the way, on the right-hand side, write this fraction, rise over run. You see the fraction? Rise over run. Notice that I made the word run like if it was going to run. And it's rising like, yeah, bam. Pretty good, huh? All right, examples, 4 different slopes. Here they go. The green one is a positive slope. And if you can see it, and by the way we're going to read our slope and our lines from this point forward, we always read from left to right. Remember how I introduced the map right now for Imperial? I went from the high school to Frank Wright. I went from left to right. You ever see that? Okay, so check this out. So the green line is representing a positive slope because if you go from left to right, it's going up. Okay, the negative slope is this one represented by the red line. It has a negative inclination. That's why if we go from left to right, it's going downward. Okay. The blue one is undefined, and we'll get to that as soon as we get to the lesson. And the 0 slope is this black line. And an easy way of remembering that one, check this out. If I was to place a marble and I did not add any force to it, and what is that law? That if an object is at rest, it would remain at rest, right? So if I place a marble hill, would it move? No, it stays at rest. That's why it's 0 slope. However, if I place a marble on this red one, it's going to fall. If I place it on the green one, it's going to fall backward. But if I was to push it with a force, it would go up. Is that correct? And if I placed it here, everybody look up. If I place it on the blue one anywhere, it's going to fall, won't it? We don't know how fast, but we know it's going to fall. That's how we know it does have a slope, but we don't know what kind of slope it is. That's why it's called undefined. Okay? Non-examples. Copy these 2. We have this one. Who remembers this graph? Yeah, right? This is a cubic function, and this is a quadratic function. These are non-examples. Non-examples. And let me show you why. According to the definition, it says change in y for the change in x, and it's always the same, that it never changes. Check this out. It keeps going. It's always the same, always the same, always the same, always the same. Look at this one. Same, 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 and then all of a sudden not the same, and then same, 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 same. So therefore, since it's not a constant change, that's why it doesn't count as an example. Let's look at this one. All of a sudden it goes up and down. There's a radical change, bless you, of rate. That's why this is also an example. So think about it. Looking at these examples and looking at these non-examples, why do you think these are non-examples? Think about it first. Think about it. Why are these non-examples? Discuss it with your neighbor, please. In order for it to be, or to have a slope, number 1, it needs to have a ratio that gives the rise over run. And the second thing, only found in linear equations or lines. That's our critical attributes. It needs to be a ratio, which is a fraction, rise over run. And number 2, only found in linear equations or lines. Are these linear equations? No, these are not. Okay, copy that, please. Steps. Okay, here we go, steps. 3 basic steps. Number 1, identify 2 points on a line or table and write the coordinates. Step 1, identify 2 points on a line or table and write the coordinates. Step number 1, identify 2 points on a line or a table and write the coordinates. Step 2, compute the vertical change over the horizontal change. Compute the vertical change over horizontal change. And step 3, simplify. Simplify. Words to circle and underline to remember these steps. We're going to circle the word identify and underline 2 points. Circle the word write, underline coordinates. Step 2, compute, and then here instead of underlying vertical change, horizontal change, I just want you to open up parentheses and write compute slope, because we know that vertical change and horizontal change is a slope, and at the end, simplify. Simplify. So, number 1, identify 2 points and write the coordinates. Step 2, compute the slope. Step 3, simplify. Step 1, identify 2 points and write the coordinates. Step 2, compute the slope. Step 3, simplify. Step 1, identify 2 points and write the coordinates. Step 2, compute the slope. Step 3, simplify. Step 1, identify 2 points, write the coordinates, compute the slope, and simplify. Identify 2 points, write the coordinates, compute the slope, and simplify. Identify 2 points, write the coordinates, compute the slope, and simplify. Identify 2 points, write the coordinates, compute the slope, and simplify. So you never the steps, please? All right, so with that said, write this example down, please. Oh, and by the way, rate of change, I'm going to be talking about that. That's another word that, another term that we use for slope. We know that it's the change in the dependent variable, which is y, over the independent variable, which is the x. All right, copy this one down with your rulers. Copy this diagram, please. Example 1. Okay, here we go. Pens down, please. Eyes up here. Pens down. Eyes up here. Here it goes. I'm going to go through the steps to make sure we got it. Step 1, I'm going to identify 2 points and write the coordinates. So I'm going to identify 2 points. The first point I'm going to identify is this one. The coordinate for that one is -2, 0. Another point, I'm going to use this one right here. And my coordinate for that one is 2 and 2. Is that correct? Okay, I'm done with step 1. Yes? So I chose 2 points and you're just paying attention. Step 2, compute the slope. So check this out. From here, from the graph, to get from the high school to Frank Wright, I go how many blocks up? Let's see, 1, 2. 2 blocks up. From this point to this point, let's see, 1, 2, 3, 4 to the right. Is that correct?
Yes.
Now check this out. The slope, we use the letter M. Remember that one when I introduced the forms of a linear equation? I said letter M stands for slope. So this is slope. Slope is equal to rise over run. So let's see. Rise is a change in y. So let's see. From here to here, how much did it rise? 2. So I write 2 over. And what is the run? 4. And what is my last step? Simplify. So my slope is 1 over 2. Copy that, please. All right, everybody look up here. Now, check this out. Some of you said, guys, focus. I'm going to plot in red 2 different points. Everybody look up. Everybody look up. Identify 2 points. Some of you said, Mr. Q, could I have used this point right here? Yes, because that line is right there. Is that correct? And some of you used this point over here. Okay, so what is my coordinate for this one? Let me see. We got 1, 2, 3, -4 and -1, -4 and -1. And this one right here, let's see. 1, 2, 3, 4 of x and 1, 2, 3 of y. Is that correct? All right, so I already identified 2 points and I wrote the coordinates. Now, what are my steps from here to here? So let's see, the rise. I'm going to go first on the rise from here. 1, 2, 3, 4 steps up. There it is. And let's look at the run. 1, 2, 3, 4, 5, 6, 7, 8. The rise is 8. So if I was to write my fraction for my slope, check this out. M equals. What was the rise? 4. What was the run? 8. And if we simplify it, doesn't that give me also 1/2. Yes, right? So, and the reason that it works like that, since it's a constant rate, it's going to be the same rate no matter where you select your 2 points. Everybody got it? Okay. No, unless you move the line to a different type of inclination, yes. But if it's the same line and you choose 2 different points, the slope will always be the same if you simplify it. Everybody got it? So check this out. So this one, the first 2 points we chose, it was 2/4. If we simplified it, it's 1/2. The other 2 points that we chose, it gave us 4/8. If we simplified it, it's still 1/2. So the slope remains 1/2. Everybody got it? No matter what? Exactly. So example 2, copy this one down, please. See if you can do this one by yourself.
Okay, I got it.
Example 2. Example 2.
Copy the same thing?
Copy that. And this one, they already give you the points. So if you want to use those, then just write your coordinates. Go. Okay, here we go. Let's see. Here, our coordinate is -2, 0. And here, our coordinate is 0, 3. Step 1 is done. Step 2, compute the change. Let's see. It goes up. Let's see. 1, 2, 3. So the rise is 3. And then the run is 1, 2. So my slope is 3/2. Can we simplify this anymore? As a decimal, but I don't want it as a decimal. This, we're going to leave it as a fraction to its simplified form. Is this a simplified form as we can get it? Yes. So that is my slope. So now, really quick. Notice this one. This is a positive slope going up. Is that correct?
Yes.
And look at this one. Positive slope going up. Okay? Now check this out. Pens down, eyes up here. Look at this one. Pay attention, please.
Yes.
Okay, check this out. So I'm going to go ahead and compute this one. Step 1, identify 2 points. They already gave me the points. Write your coordinates. We already have coordinates written there. Are we there? So now, I need to compute the change. Now, to get from this point to this point, it looks like it's going down. Is that correct? So I take 1 step, 2 steps on the negative direction. So this is going to be -2. Did it go up? No, it went down. So that's why I write -2. From here, how many steps to the right? 1, 2, 3, 4. So therefore, let's see. Slope. What was my rise? -2. And what is my run? 4. If we simplify that, that gives me -1/2. Are we there? Okay. So now, for homework, we got pages 276 to 278, numbers 1 through 35. I want you to read, and we're doing odds. I want you to read the second part of this lesson, which is using a formula to compute the slope using 2 points. That's the only thing that's missing. Okay? What's that? Yeah. And that's the only thing that's left. All right? So enjoy your homework, guys. Show me your notes for your ticket out. And I'll see you guys tomorrow.